Hi, thank you to the organizers of Strings 2025 for this wonderful conference. And I'll also like to thank the organizers for giving me this opportunity to present some of my work. So today I will be sharing about a work done in collaboration with Alec Pedroia on if string stars exist in higher dimensions, specifically in space-time dimensions d greater or equal to 7. So from analytic analysis and plenty of numerical evidence, our study seems to suggest that the answer to this is yes. So the motivation of this is in perturbed corners of quantum gravity, we seem to always see Schwarzschild black holes undergo a phase transition. In the case where you have a decompactification, the black holes undergo what is known as the Gregory-Laflamme transition. And in the case where we have a weakly coupled string disruption, or what is known as the emergent string limit, the black hole undergoes a phase transition to a thermodynamically more stable saddle, which is known as the Horowitz-Wilczynski solution. So in previous studies, it has been suggested that if we consider interactions of the leading order between the winding mode and the radion, then these bounded normalizable solutions called Horowitz-Wilczynski only exist in space-time dimensions d less than 7 and greater than 3. So then the natural question is what happens to black holes in dimensions d greater than 7? So it turns out that if we include higher order interactions between the winding mode and the radion, we can modify the equations significantly, such that we can potentially construct new bounded normalizable solutions, which we will call string stars. With higher order interactions between the winding mode and the radion, the equations of motion become more involved. So one of the simplifications we will make is that we will study these systems at Hagedorn temperature. And there will be an enhanced SU2 symmetry specifically at Hagedorn temperature that was noticed by Baltazar, Chu, and Kudasov. The equation is simplified to the following form, where we can think of chi now as the position of a 1 + 1d particle moving in a potential that is described by this figure to the right with friction. So this leads to three types of solutions: an unbounded solution, a bounded solution, but there are two types of bounded solutions that we may encounter. One scales as r to the -2 asymptotically, and one scales as r to the 3 - c. So we set out to precisely do this, and we find that for small chi, where we have good perturbative control, we always observe that these solutions are bounded and scale as r to the -2 asymptotically. As we slowly increase away from perturbation in the perturbation regime, where chi reaches of order 1 at small r and eventually decays asymptotically as r to the 3 - d, we have been able to find these precise bounded normalizable solution with finite non-zero free energy. So one might speculate that as we increase chi 0 up to order 1, alpha prime corrections will be important, and that is correct. However, the universal asymptotic behavior of r to the 3 - c remains true despite what happens to the potential at small r. So these are all found in d greater than 7. So then let's return back to the case where we are in d equals to 7. So in d equals to 7, much thanks to the quartic interaction, we are also able to construct new normalizable solutions, but from a different perspective. In particular, in this case, we won't have to be strictly at Hagedorn temperature, and our profile and the winding mode and the radion scale linearly with the perturbative parameter, in particular, the difference between the actual temperature of the system and Hagedorn temperature. So from this, we were able to construct bounded normalizable solutions for the winding mode and the radion, which we illustrate to the right. And we were also able to compute the free energy and as a function of temperature. And these are distinct from the lower dimensional Horowitz-Wilczynski solutions, as the scaling of size in terms of temperature behaves differently. So last, I would like to conclude that at Hagedorn temperature, we have been able to find string stars with finite non-zero free energy in d greater or equal to 7 space-time dimensions. And extending our analysis to 7D, we have also been able to reproduce the free energy of 7 + epsilon d string star that was computed at Hagedorn temperature in Baltazar, Chu, and Kudasov's work. Thank you.